Hello everyone, my name is Alvaro, and in this video I will be going over another problem from the blind Leetcode 75 problem list. Today we will be doing problem 242, which is called valid anagram. This is a problem that you might encounter in internship interviews, and it will be a simple one, so definitely one to keep track of, but usually if you get asked this question, you will probably be asked like maybe one or two extra questions. But it's definitely a good practice, especially for beginners who are still trying to get into Leetcode and maybe practice with strings. This would be one of the problems that I would start with, for sure. So let's get to read the problem statement, and then let's get to solve the problem. So, given two strings, S and T, return true if T is an anagram of S and false otherwise. An anagram is a word or phrase formed by rearranging the letters of a different word or phrase, typically using all the original letters exactly once. So example 1 returns true because S and T are anagrams of each other, and the reason why they're anagrams is because we have 1, 2, 3 A's here. We have one N here, one G here, and one R here. So they have the same letters and the same amount of each letter. And this one is false because they have the same amount of A's and R's, but one has a T and the other one has a C. Okay, so if you want to try this problem by yourself, now will be a good time to pause the video because I will discuss how to solve it. So our approach will be the following. The first quick check that we can do is simply, because each string is composed only of letters, lowercase English letters, it means that if they have, it implies that if they have different lengths, then they can't be anagrams of each other because one of them has an extra letter than the other one hasn't, than the other one doesn't. So either they have that string has a letter than the other one does not have, or has an extra letter of a letter that the other one has, if that makes sense. So the first check that you should do in this question is, if the length of these two strings is not the same, then it's impossible for them to be an anagram of one another. So we can just write that down real quick. So if the lengths are not the same, then we return false. And then we can start to actually loop through the strings and see if they're anagrams. So the basic idea here is to use a hash map or dictionary in Python to keep track of how many times each letter appears in the original string. Let's do S. We can do T first, it doesn't really matter. But let's start with S. So the main idea is that in the hash map, the keys will be the letters, and the values associated with those keys will be the amount of times that letter appears in the string. So for example, if we are making a hash map of this S right here, one of the keys would be A, and the value associated with A is 3 because there are 3 A's in this string. The same thing with an M. The key would be an M, and the value would be 1 because there's only one M in this string right here. So we will loop through the array, and whenever we encounter a letter, we have to check first if it's in the hash map, and if it's not in the hash map, we create a new entry with the value 1, and if it's already in the hash map, that means that we have encountered that letter already, which means that we simply have to increase that count. So that'll process the letters that exist in S and how many times each letter appears in S. So let's get to that. So for each letter in S, also we haven't defined the mapping, so we can just call it like this. So if letter is not in the mapping, then we can say mapping subletter. We create an entry for letter and we make it 1. Else we say mapping letter plus equals 1. And that means that we have processed every single letter in S. Now what we will do is we will compare T with the mapping. And what's going to happen here is we are going to loop through T, in the same thing and the same way that we loop here, so for each letter in T, but we're going to do slight different conditions. So the first thing is that if we encounter a letter in T that's not in the mapping, then that means that T has a letter that S doesn't. So T can't be an anagram of S in that case. And if that's the case, we will simply return false at the moment that we encounter a letter that's not in the mapping. If it's in the mapping, what we have to do is we have to decrease the count of the mapping of that letter by 1. So that's how we would process the string T. So for a letter in T, if the letter is not in mapping, then we return false, else mapping letter minus equals 1. And at that point, we have processed every single letter in T and S. But we're not done yet, because it could be the case, for example, that suppose that this string right here, instead of being Nagaram, okay, it's something like, let's see, where are you? Okay, right here. So suppose that it's this. So in this case, the string would have, once we process S, the hash map will be A is 3, N is 1, G is 1, R is 1, M is 1. And as we loop through T, right, we are going to subtract 2 of A. So now A would be 1, N would be 0, G would be 0, R would be 0, and M would be 0. The strings will be anagrams if for every key in the mapping, the value associated with that key is 0, which means that we have encountered the same amount of each letter in T as in C, as in S. If one of the values associated with the keys is not 0, that means that that letter has been encountered either more or less times than in S. If it's negative, then that means that T has more of that letter than S. And if it's positive, like in this case, A would end up being 1, then that means that T has less letters of that letter, less occurrences of that letter than in S. So now we have to check every single letter in the mapping. And if one of the values is not equal to 0, then we return false. And after we're done looping through that, we can simply return true. So for each letter in mappings, and remember that in the mapping, the keys are the letters, so we loop through the keys. If mapping letter is not equal to 0, then we return false. And if we're done looping through everything and everything is equal to 0, then we simply return true. And this should work. There you go. Obviously, runtimes, as usual, a bit inconsistent, but nonetheless, this is the optimal solution. So what is the runtime of this solution? The runtime of this solution is big O of n, where n is the length of S, because if these two were to have different lengths, we don't even navigate the second string. So it wouldn't be n plus m in that case, because we simply check this, right? So in the worst case scenario, we traverse 2 strings of the same length. So the runtime will be 2 times n, which is big O of n. And what is the spacetime complexity of this problem? Well, in the worst case scenario, the string S contains one letter of each, so every single letter is different. Therefore, we will store n letters in the mapping. So the spacetime complexity in the worst case scenario is big O of n. So the spacetime complexity of this problem is big O of n. And that's pretty much it. I hope you enjoyed the video and that you found it helpful as usual. And see you in the next one. Bye-bye.